Okay, welcome back. Today I want to talk about variables, data. Making a summary about the things that you already know, variables, objects, and arrays, and introducing a new topic, references. So, talking about data in your programs, the first thing that we learned was about variables. And when we review variables, we review data types, primitive data types. We reviewed this idea that in order to store data in one of your programs, you need a place in the memory. That place receives the name of a variable. That place have a particular size and use a particular format to store the data. The size and the format, you specify that with the type. For instance, when you use int, the size 4 bytes and the format, well, a binary number. But the format for the int or for double are different. So you can have a floating point number that is going to be maybe the same size that an integer number. However, because they are stored in a different format with a different organization, they have different sizes. The minimum number or the maximum number is different. You specify the size and the format with the data type. And then you give a name to your variable. So this, in the memory of the computer, and this is important, today we're going to talk about memory and memory addresses. When you think about what is the meaning of this inside of your computer, what we have been representing is, well, it's a box. Yesterday I mentioned this. It's a box, but that box, talking about the integers, well, is really 4 spaces because you have a box and the size is 4 bytes. So even though you use the box like to store one number, 0 maybe, well, maybe you are using 4 spaces in your memory, right? Now, that box have a name in your programs. Every single time that you want to do something with that box, you're going to name that box X because that is your variable. And as we mentioned before, the type for that X is the type of the information that you can put inside. Now, something important that I want to introduce today. We agree that that box is in the memory of my computer. Each of those bytes have an address. If you think about the memory of your computer, is all these small boxes, bytes, and each of those bytes have an address. You need some way to specify, to access each of those positions. You do that with an address. Just like with arrays, you use the index, 0 to something. You can imagine this like the memory in your computer, a big, huge array in which the first byte is 0 and then you move forward, right? And your program is just running there. So I really do not know in which position this variable is going to be running, but it should be in some place. What I am going to use is a random number here. I am going to use this notation 0x, used for you to know that I am talking not about the value, but I am trying to represent where in the memory this variable is. 12, 50, 100, 1000. Use some random space in the memory. What I want you to be aware is every single time that you create a variable, well, you are using 4 bytes in the memory of your computer. And the address is the address for the first byte. Yesterday we talked about it. This variable is using the byte 12, 13, 14, and so on, is using 4 bytes, but we assume that the address, the direction of the variable, is the address of the first one. And because we have the address of the first one, and we know this is integer, and therefore the size is 4, well, starting with the address and using the next 4, we have our box, and therefore we have access to whatever is inside. This is with variables. Very easy, really. Now, what I want to talk today is, there are other 2 things that we have reviewed for data. At this point, we talk about objects, right? We have been working with classes, student, professor, university, and so on, and we have been creating objects. And I have been using this circle to represent objects. What happened with the objects when they are in the memory? I want to talk about it. The second thing that now we know for data is arrays. Objects and arrays is something that we review in the last weeks. When we think about arrays, yesterday, Monday, I showed you, well, your array is a collection of variables all together, consecutive in the memory, something like that picture. There is something common between objects and array. They have one particular thing that make them be similar. Do you remember when you create an object, when you create an array, what they have in common? What is similar in our program when we're working with objects or when we're working now with arrays? There is one thing that is similar. We use the keyword new, right? Do you remember? Every single time that you create an object, every single time that you create an array, for some reason, I have been asking you to use the keyword new. Something is going to happen there. Now, talking about the memory, objects. So far, you know that, for instance, in order to create an object, well, student is equal new student. I am using the new there. For the array, yesterday, something like this, right? What happened in the memory? So far, I draw this circle. So far, we have been using the name S for the circle. Somehow that one is the object S. We have this array A. Yesterday we talked about, well, that is the array. Regarding the question in the chat, can you create arrays and put objects inside? Yes, and I am going to show you that. Today we're going to put all these 3 things together. Before that, I need to tell you something. Really, this S is not the name of the object. This A is not the name of the array. What happened in the memory when you do this or when you do this is the following. In the memory of your computer, you're going to have a box. This box has the name S. And then here, the new is going to create an object, the circle. And what is going to happen is this object have an address. That object exists in a particular place in the memory. There is 1 byte. That is the first byte of this object. I am going to use a random number. If we think that the object is in the address 55, in this box, what the computer do is to store that address. Did you notice the difference? This one is not the name of the object. The object, the data that you put together, do not have a particular name, have an address. I store that address in a box, just like the variables that we used before. This box have the address. And usually what you're going to find on the books, what we do in terms of explaining this is because the box have the address, like because someone have the address of your home, that someone is able to point it's a pointer, or that someone is able to provide a reference that indicate where is the data, where is your home. Every single time that you create an object, every single time that you run an instruction like this, two things are happening. The first one, you're creating a variable. The name for the variable is what you choose as a name for the object. Not really for the object, but for the box. That box stores the address of the object. And the name for this box is, in Java, a reference. Every single time that you create an object, you're creating a reference to the object also. Think about this like you have a car. You cannot put your car inside of the classroom. So basically, you put your car in the parking lot, but you go to the classroom and you keep the keys. The keys are this reference, this pointer, this element that give you access to the object. Remember that I told you, you can do this line together, and that line is doing all this draw. Now, if you think about it, something that you can do you can split this line in these two lines, right? We did this. Now, when we talk about these two lines, something that I told you is, if you do this, but you do not do the new, and you try to use the object, you're going to get this null pointer exception error. Remember, null pointer exception when you do not do the new. Now, I can tell you this line, the first line, student S, that is the line that create this box. The box that is the reference, the box that is going to store the address of the object. This first line is going to create a box. Just like before, this line int x create a box. Student S, a box. The difference is int x is a box to store integers. Student S is a box. It's not a box to store students. It's a box to store the address of a student. The address in the memory in which the object is going to be. Now, this instruction new is the one that go to the memory, create the new object, and then this new is the one that is going to put the address of the object that was created inside of this box. And just because the box has the address, with the name for this is, the fancy name for this is, that one is a pointer, that one is a reference to the object, in the same way that having the address of your house, someone can point or reference your house or your car in the parking lot, whatever. The reference, the object, and the equal connect them. Make sense? That is the reason, because when I told you that if you only do student S or student W, the only thing that you are doing is the box. Did you notice? There is no equal, not here, not here. Do you remember what is the initial value for an object when you do not put a value there? Null. Null is the value that you're going to have here. In fact, let me tell you this. In the same way that false is just a fancy name because there is no false in the variables. The computer stores a 0, and the meaning of that 0 in a Boolean variable is false. In this case, similar idea. There is no null value. Null is just the fancy name for storing an empty address, an address that do not exist. 0 if you want. There is not going to be anything in the other 0 for your program. But just to be aware that we're talking about references, pointers, addresses, we're going to use this null as the initial value, the empty value. When you have a pointer and S, W, if I ask S to access a variable inside, to execute a method, whatever. If you remember, we have the class student, and inside of the class student, we have some methods, solve the quiz. If I ask solve the quiz and I use S dot, well, the S is going to go here. It's going to read the address. The dot is the jump. The dot is go to that address. So S, 66, go to the address 66. Okay, I am here. In this address, search for the method, solve the quiz, run that method. In this case, if I try to use W and then I try to do the call to solve the quiz, the reason because you're going to receive this null pointer exception is because, well, I can go to W, but W is empty, so I cannot go to any object. There is no object here being pointed. And if there is no object, therefore, I cannot run the method. There is no address. In order to jump, I need a valid address to go to. The null is this idea of I do not have an address. Like I do not have the keys for the car, so no access. This is what happened with objects. Again, every single time that you have an object, the new is the one that gives you the object, but always you are creating a reference. So all these times that I draw an object, a circle, in the book, in my slides, usually we represent the object as a circle to talk about the object itself. But every single time that you saw an object, just remember, the name is this name of a small box that is pointing to that circle. That is really what happened in the memory. So for primitive variables, you have the box with the value inside. For objects, you have the box with the address inside. This particular box is called a reference, and then you have your object. Now, what happened with arrays? Because we just mentioned before, arrays are also using new. Arrays. Yesterday, we did this, an array of integers, new, the type, and the size, variables or numbers. I am going to use a number. If you remember, in my slides at the beginning, I showed you step number 1. Well, this new here is the one that is going to create the array. The array, the 5 elements that I am asking for. Each of them, you use the 0, the 1, the 2, the 3, or the 4. 5 elements. Now, that array, yesterday, we talked about, well, they are like 5 variables consecutive in the memory. They are like 5 integers together. Help me, what is the size of the full array? How many bytes do I have from here to here? All the array, do we know? $40, $20, okay, 20. How do we know that it's 20 bytes? 5 times 4. 5 integers, each integer is 4, so you have in total 20 bytes, good. Now, we really don't care about the address of each of the 20 bytes. The only address that we care about is the address of the first byte. And again, I am just going to use a number here, but just imagine that the first byte is an address, and that one is in the address 48. Again, I am using numbers, random numbers. Just imagine that the array got there. What I have is because this instruction, the new, I have my 20 bytes, 5 integers, each integer 4 bytes. But then this instruction here is the name of the array. It's not the name of the array. It's the name of this box here. The type for that box is int. And what that box is going to have is the address of the first element. And again, in terms of a fancy name, what we say is that one is a pointer, a reference to the first element in the array. You have your array, we call the new, and the name, just like with the objects, is the name of a variable, a reference that stores the address of the first element. Now, I have the address of the first element. I know the type of the elements, integer, 4 bytes, and I know how many elements I ask for. So I have enough information to know the space in the memory that I am using. I am using 5 elements, each element 4 bytes. I am using 20 bytes, and the first one is in the address 48. So I am using from the address 48 to the address 68, 20 bytes. The computer knows that. The computer can take care of the details, but this is the representation that I have. Always, 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 when you create an object or when you create an array, this is what is happening in the memory. Makes sense? Now, the same thing that we did yesterday is like, if you do something like int a, that one is going to compile. Yes. What is going to happen? You have a box. Let me use another name. You have a name, is this one. The type is an array of integers, but you didn't put any value. The value for that one is going to be null, just like with the objects. Now, what happens if I try to use b in the position 0 equals 5 or whatever? Well, this is b. You create the box, but the address that you have inside is null because it's the value by default. So when you try to do this, that one is going to be an error. That is the reason because you need the new, because the new is the one that really creates the objects or the space for the array, whatever you are doing. Here with a, when you do something like a in 0 equal 5, a is this box, address 48. Address 48, go to that address, and then you can search for the element 0, the 1, the 2, the 3, the 4, in this case the 0, and put there this value. But always is go here, follow the reference, and that gives you access to the data. The reference is your door to access the data. Okay, so tricky things that you can do. So you're telling me that this one is A, and A have the address of the first element in the array in blue. Now you're telling me that this line is going to create B, that is this box a reference, but this one is not pointing or referencing any data. So basically I cannot use B until I use new to create the space, right? I have a question. Can I do B equal A? I mean, this is B and this is A, and looks like they are the same data type, right? Int, square bracket, int, square bracket. They look like same data type, two variables. Maybe I can do the equal. And the algorithm is, yes, you can. I mean, same data type. Now, be careful. Can I do, and this is a question for your exam. Remember that I have here this variable int x, right? So if I have this variable int x, can I do this A equal x, or can I do x equal A? Can we agree that you cannot do that because they are different data types? But they are integers. No. X is integer, but A is int, which means array of integers. Integer, array of integers. They are not the same. This is going to fail. Your compiler is going to tell you you are crazy. These are apples, these are bananas, do not match. However, for this B and for this A, they are exactly the same. So I can do that. Now the next question is, if I do that, what is going to happen? And this is critical. If you have two variables, int x equal 5, and then you have a variable int y, and you do y equal x, can we agree that you have x with the 5, and now you are creating y, and when you do this y equal x, what you are doing is to copy the value from x to y, right? We review that with variables. Following that exact rule, what is going to happen when I do b equal to a? Well, you are going to copy what is inside of A inside of B, right? I mean, it's exactly the same that before with variables. Now these are references, but it's the same operator equal. Is copy what is inside of the box in the right to the box in the left. So you're going to copy the address. You're going to copy the 048 inside of this one that was empty. And you get the idea. What you have now is this guy, according with my explanation before, is pointing to that address. I have two references, two pointers to the same array, two keys from the same car, or two keys for the same house. The important thing here, guys, is this one do not mean that now B is or has an array of 5 elements. In any moment, I use the new again. So I am not creating another array. I have only one array, the one that belongs to A. But now this B is pointing to the same one. 2 pointers, only one collection of data. What is the meaning of that? Yes, you get to the point. The meaning of that is, well, what is going to happen if I tell the computer B in the position 0 is going to be equal to 100? Can I do that, yes or no? Or is it going to be an error? Because remember, we haven't used the new for B. You haven't used the new for B, but now B is not null. And remember, the error is when you have these boxes with the value null. In fact, the error is null pointer exception. So the problem is the null. B is not null. B is 48. If you ask B in 0 equal to 100, B, go to that address, search for the 0, put the 100 there. What happened with the 5? Goodbye. It's the same array. 2 references, 2 names. You can use one or the other. What is going to happen is any of them can read the data or change the data. Well, different sizes. This can be interesting, right? Another example. Let's see. Crazy things that can happen in programming. I want an array. A1. And this one is going to be new integers. And this one, the size is going to be 3. And then I want to do another array. And that one, the size, 10. 2 arrays. One with 3 elements, one with 10 elements. Very important thing. I need you to be able to visualize what is the meaning of these instructions. I need you to be aware that those instructions, when the computer executes the instructions, what is going to happen, and now you know, is, well, you're going to have A1. A1 is going to have here the address of the first element of the 3 that are going to be created by the new 3 integers. If you think about it, this is 0, this is 0, this is 0. Initial value, remember? They are integers. The initial value is 0. Which is the address? We do not know. It's something that the computer is going to do, but used for the example purposes, maybe here I have a 0x40. Just think that the 40 is the address of this first element. And exactly the same is going to happen with A2. A2 is going to have the address of the first element in an array of 10. And so far, this is what I have. So far, I can do A1 in the position 1 equals 7. And I am going to have a 7 here that replaces the 0 that I had before. A2 in the position 1 equal 10. And I am going to have this 10 here that replaces the 0 that I had before. Okay. What happened if can I do that? It's going to compile A2 equal A1. According with my example before, yes, we can do that. What is going to happen? Because number one, can we do that? Yes. A1 and A2, same data type. Remember, the only concern when you use equal is you should be working with the same data type or equivalent data types. So int and float work, but you cannot go from object to integer. That is going to be crazy. In this case, A1, A2, both are arrays of integers. Fine. Consequences. Well, following the rules that we just described before, if you make A2, this one is A2, equal to A1, can you agree with me that I am going to copy the value 0x40 in the box A2? This value is going to be copied in this box. I mean, use normal. What is going to happen with the 0x10? Goodbye, right? So 0x40 is going to be there after this assignment. What are the consequences for that? Well, very important consequences. Number one, now A2 have the address 0x40. So this arrow that I draw there do not exist anymore. A2 is not pointing to the address 10. A2 is not pointing to the first element of the array with 10 elements. Now A2 is pointing to 40. A2 is pointing to the same address that A1. Now, here, several things are going to happen. Your question in the chat. Number one is like, what is going to happen with these 10 elements here? Someone is pointing to them? No. So if no one have the address of those elements for the computer, those elements are garbage. Do you remember, maybe you read about garbage collection in Java? One of the main tasks for the Java virtual machine is to recollect garbage. What is garbage? All these spaces in the memory that no one can use. Why no one can use this array of 10? Because no one have a reference and access to them. Because remember, you know that they are in the address 10 because I use this value randomly. But really, when you run a program, that address could be anything. Those arrays are considered garbage, all those 10 elements. No one is pointing to them. Usually the example is, just imagine that there is a car in the parking lot, but no one have the key. In some point, the garbage collection is going to go look to the car. This car has been here for a long time. No one is using it. garbage, delete. Delete. The virtual machine is automatically searching for garbage and killing things, deleting things. There is any way that the garbage collector can go and tell A2, hey, you lost this? No, that is the programmer responsibility. The only thing that the garbage collector do is delete things, clean things. There is a car in the parking lot, no one is using the car, remove the car because we need the space in the parking lot. So that is kind of the philosophy for the virtual machine. Okay, now, the next step of the consequences. If I remember correctly, A2 in some point have 10 elements. So with A2 in some point, I could have done something like A2 in the position 5 equal 9. What happens if I do this now after this assignment? Out of bound exceptions. But why? A2 was 10 elements. A2 before this. Now A2 is this guy. Now, if you do A2 in the position 1 equal 1, what is going to happen is that you're going to delete the 7 that before you put there using A1. Now you have two keys to the same car. It doesn't matter who do what, but the car is the same. The space is the same. So one variable, one reference can be adding things and the other can be removing things, or they can be fighting each other to put something there. Be careful when you use equal with arrays or with objects. Similar idea is going to happen with the objects, and I am going to show you examples. But so far, this is the idea: references, memory addresses. Good. Now I can go back with the slides. So, all the things that I mentioned. Assignment with primitive data types. Very simple. If I have something like this is the original. Number 1 is 5, number 2 is 12. After you do this assignment, you know that this is going to happen, right? The 5 that you have in 1 is going to be copied in 2. So now both have the same value. What happened with the 12 do not exist anymore because you replace it with the 5. That is what the assignment do. That is the operator assignment, the one equal. That happened with the primitive data types. Question for your exam: how many primitive data types do you have in Java? And maybe I can ask which ones. Names. Boolean, byte, short, int, long, float, double, char, 8. You remember, those with the lowercase. The string is a class, right? Now we know that. Okay, whatever. With all those data types, this is true, this is working. References. I just explained this to you, but I put the information on the slide. The most important thing that you need to remember is when we are talking about references, we are introducing the concept of memory address. A reference is a variable that stores an address. What is a variable? A place in the memory that store a value and have a type. What is a reference? A variable, but store an address. When I say it's a variable, that means it's also a space in the memory. It's a space in the memory storing the address of another space. It have a type. When you create an array of integers, you have a reference to the array of integers. When you create an object student, you have a reference to an object student. The address of an array is not the same as the address of an object. The address for an object student is not the same as the address for an object car. The objects have different sizes. And remember, the data type gives me the size. Each data type, different size. Good. So when you create an object, now we can agree in those examples before, when we create object students and we create Jane and we create John, we play with those two objects. And at that point, the circle was a good idea. I explained you the variables, private, protected, the methods. Now I can extend that idea. And this is Jane, really. A reference and the object. This is John, really. The reference and the object. And my second picture here. What do you do to go from this to this situation? Arrow here, arrow here. Can we agree that exactly that line was executed? Something that I want you to be aware is usually if you have two objects and you're thinking about like, oh, this one is Jane and maybe Jane have 100 in the class and the ID of Jane is 1, 2, 3, whatever. And this one is John. And I don't know, you don't have an 80 on the class, and maybe the ID is 3 to 1. Just random numbers. If you are thinking that doing John equal Jane is going to copy this grade there, and this ID there, and this name there, my point is, no guys, that is not going to happen. What happened is, because the previous explanation, because what you told me in the chat is, there are not going to be 3 data going from one object to the other. There is going to be only one. Which one? Well, whatever value is here, that is the address of the object, is going to be copied there. And because you are copying the address, well, now you have these 2 boxes pointing to the same object, pointing to the same data. So good news is if you print John, you are going to be printing this data. And you can think like, well, we achieved the goal. We copied this data here and we have now both with a grade 100, both with the same ID, both with the same name. You do not have a copy. You are accessing the original data. You have only one copy. And if by any chance you change the grade for John, or if you change the grade for Jane, you basically are changing the same number. What happened with all the information that John has in this circle? This circle, this object become garbage, In some point, the garbage collector, the Java virtual machine, is going to arrive and kill, delete, do not exist anymore. Objects, arrays, the same criteria. Now, to be more specific, what I want you to be aware is two objects. This instruction, if you, for any reason, work with setters or getters for a student 1 or for a student 2, it doesn't matter. They both are working with the variables here and the methods here. As I mentioned before, whatever you have here in the original address connected with the first student become garbage. Yes, there is one particular reason. Question in the chat, there is any reason for having this kind of stuff? Only one case that you want to have something like this. Do you remember methods? Do you remember parameters? What do you think is better? To pass as a parameter the object, the array, I mean, all the elements, all the data of the object, or just pass as a parameter the address? We're going to play with that, but I am hoping that you agree with me, the address is better. Usually, if you want to give access to a friend to your car, you do not give the person the car. I mean, you do not arrive with the car and here is my car, you can use it. Here are the keys, the address. Therefore, with the address, you can go and access the car. Similar idea with the home, your house. Here is the key, or maybe here is the address, so you can go to the address. When we are working with data, between one method and other method, between one class and another class, what you are going to be checking is, you know what? I have this array with the names of all my students. Instead of checking the array with all the names, what I can check is, here, this is the address, the reference, the address to the first element. And that method or that class or that program can access not only the first one, but all of them, used with the address. And the address is one number. And one number is just 8 bytes. And maybe the information could be a terabyte of information, a gigabyte of information, 100 bytes of information, I don't know. But it's cheaper, easier to share the address than sharing the full information. In these examples, I have both the students, maybe in the same method, maybe in the same class, because I am showing you an example. But think about it. What if this student is in one class, one file, and this one is in another method in the same file, or maybe in another method in a different class? You can have two methods, two classes, sharing the same data. That is the reason we want to have something like this. Make sense? Sharing data. If you think about a classroom, what we have in a classroom, thinking about objects. In a classroom, we have this professor, that is one object from the class professor. We have this group of students. Now I can tell you, it's an array of students. The size of the array is the number of students that enroll in the class. So our classroom is one professor and an array of size students. I need to talk about arrays of objects yet. But if you think about the whiteboard, who can use the whiteboard? The professor, but also the students. The whiteboard is an object. And the professor and the students have the address of the first byte of the whiteboard. It's the same whiteboard. It's not like every single one have a new one. All of them have access because all of them know the address of the first byte. Why that is important? Well, we have a whiteboard here with Zoom. I can put my PowerPoints here in the screen that I am sharing with you, and I can enable you to be able to draw or put notes on my slides. What is happening, even working remotely, we're sharing information. And most of that happen sharing the address of the first element. We do not make copies of the same data several times. The data is in the server. You, as people that is connected, have access to that place. And you have information in one variable about where that data is, the picture of my slides. And therefore, you can manipulate that data. You do not have the data, a copy of the data, each of you, because it could be too expensive. References, pointers. Good. So we need to move to that. So far, easy examples used for you to play and get the idea of what happened. Now, next, arrays. This picture I showed you before, and hopefully now makes sense about why this picture of this is the array, but this arrow, it wasn't clear why the arrow, because arrays are references. Every single time that you create an array, you create a reference, and the reference point to the first element. The example that we just reviewed before, I want you to have that in the slides. Do we understand these two things, the code and the picture in the memory? This picture is 100% clear. Please tell me yes. Good. Guys, one of the most important things that I will recommend you for your exam, in your exam, now for the final, when you are answering questions about, hey, what is the result of this code? And that code involves objects and or arrays, please use your paper. Remember, you can use paper. And in the paper, draw something like this. Be sure that you understand where are we using references, which ones are the values, what is connected with what, and then with that picture, then you can answer the question. Because basically what we're going to ask there is to evaluate your understanding of something like this. These are not two arrays. These are two references with only one array. And if that description is clear, we're moving forward. If not, please, now is the time to ask. If not in the chat, send me an email later. But very, very important to understand reference and data. The difference between the data itself and the multiple addresses in the memory that we can use to access that data. Good? Now, the last thing that I want to tell you today, and you asked me at the beginning, is like, well, we talk about variables, we talk about objects, we talk about arrays. The arrays, well, are a group of variables, right? Can we have arrays with objects? Yeah, that is the last thing that we can do, the complex things that we can do. Well, almost, for now. And I would like to show you what happened. Number one, if you read that line, what can you tell me that line is doing? Hopefully, the first thing that you're going to tell me is an array. And the reason because you're going to point out an array is because we're going to read this thing here and these things here. So there is no doubt that there is an array involved there. And it's an array of 5. And then I can ask you, well, it's an array. It's an array of 5. 5 what? And in that point, you're going to search for the data type. And you know now that this one here before the bracket should be the data type. And this one here after the new should be the data type. So can you agree with me that that one is an array of students? An array of students. Okay. I have a problem there. An array of students. So you are telling me that I am going to do student, data type, I want an array. Are you telling me that with something as simple as that, I can create an array, the array is 5 elements, and now changing only the data type, instead of int, now I put student and I have an array of 5 students? Yeah, I mean, the language follow the same rules for whatever you want to do. The only thing is change the word. The important thing here is what is happening in the memory when you do this. Let me do a comparison. What happened in the memory if I put int, new, int, the same size, identical. The only thing that I do is A, B, one is student, the other is int. What happened in the memory with B? According with what we reviewed today, B is going to be use a box, that box have an address, and the address is pointing to the first element of this group of 5 elements. I am going to draw down just to have a space here and put the 2 examples together in 2 columns, but remember, there is no relationship between horizontal or vertical for the arrays. It's just a draw. It's a picture to represent what is in the memory. And the memory is not bidimensional, so you don't need to worry about horizontal or vertical. So if I draw this, B has the address, whatever is the address of the first element. Can you tell me what is the value here, 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 and here inside of B1, B2, B0, etc.? Can we agree that the initial value for the elements is 0 because 0 is the initial value for the integers? Makes sense. And then you can play with B in the position 1 equal to 7, an integer. And this 7 is going to be stored here. And that 7 is going to replace the 0. Following the same idea, but with A. A box, the address of the first element of a group of 5. A group of 5. Why are you drawing boxes? A student is an object. Where are the circles? I do not have circles yet. Why? What is the initial value for the elements? For integers, 0. For objects, that is what you have when you create an array of students. So we do not really have an array of students. What we have is an array of student addresses. Yeah. Okay, that is not useful at all. Well, we have an array, but it's empty. B was an empty array of integers. But then I put 7 in the position 1. What about A in the position 1? What can I put in A position 1? Exactly. This is A position 1, and if the initial value is null, you can remember, well, that is the address. What I can put there is the address of a student. And which is the instruction to get the address of a student? In particular, which is the instruction that create a new student and give me the address? That is the instruction. And what is going to happen with this here? Well, this is going to have an address. And that address is going to point to a new object. An array of objects is kind of this array with the keys of 5 cars. The cars are not in the array. The array is used an array of references to the objects. In this case, an array of addresses. So I have these boxes. This one have the address of the first element in the array. And the elements in the array, each of them have the address of a particular object. When you look at an array of objects, what you're going to have is some of them are null, could be null, but the ones that are not null are basically pointing to objects. So this connection, like a tree, is really what happened in your memory when you start working with put together arrays, and now arrays with elements that are not primitive data types. So according with this description, what you are telling me is if I want to create an array with objects, what I need to do, number 1, is to create an array. Now you are telling me that if I try to do something like access the first element of the array and call a method, doing this immediately after creating the array is going to give me an error. Why? Is that true? It is true. Get ID, the element 0. Well, what happened is that right now the element 0 is null. Remember? The element 0 is null. If you try to do, in this example, A in the position 0, dot, and get whatever, the element 0 is null. And if you try to use a method with null, it's going to fail. And it's going to fail null pointer exception. Null, the value. Pointer, this arrow that I am drawing. pointer or reference. For Java, they are kind of the same. In fact, Java do not use the term pointer only for the error. Java use the term reference. Later in C++, you are going to learn the small difference between a pointer and a reference. So far, you can think about them like synonyms for Java. So what you need to do after the line number 1 is this. For each element in the array, you need element 0, element 1, element 2, whatever. All of them, after this line, they are null. What you need to do is to change that. Each of them should be equal to new. And hopefully you notice the difference. When you create an object, the type is a student, but then you have parentheses. You are calling the constructor, remember? When you create the array, even though you are using new, and even though you use the type again, here, square bracket, and the size is not parentheses. You are not creating the object, you are creating the array. You are specifying the size. Here, you are creating the object. You specify the data for the constructor. In this case, the name, for instance. Second option, you can do 1 and 2 separate, or do you remember yesterday the initialization list? Do you remember that is one way to avoid the new for the arrays? You can avoid the new if you provide initial values. You can do this for an array of objects, and this is the same that 1 and 2 together. Values, these news, are new students, new objects, separated by commas. Inside of these curly brackets, initialization list, and then your array. When you do an initialization list for an array of integers, here inside of the curly bracket, you put the integers. Now, if you want to do an initialization list for an array of students, inside of the brackets, you put objects, students, like these things. Arrays of objects. And just to check my draws, the first time, all of them are null. The array is empty. Anything that you try to do, null pointer exception, because all the nulls. When you do the next new, when you put an object there, this is what you really have in an array of objects. Help me. This is an object, right? And inside of this object, maybe I have a method, say hello. What can I do to call the method, say hello, for the first student in the array list? What is the Java instruction for calling the method, say hello, that is in the position 0 in my array of objects, and the array name is list? Thank you. Name of the array, correct. The position in the array, correct. So, do you remember? Name of the array, the position. But now we have an array of objects, the dot, the parentheses. Array, square brackets, and then the dot, because we are back working with objects, and then the name of the method. I just put together two things, arrays and objects. Both need the new instruction. And a little bit about what is happening in the memory of the computer. So far, any question? Good. This is one of the most important topics together with arrays. So this week we review arrays 1, arrays 2. Today I start with references. I am going to continue with reference tomorrow. And those two, very, very important in your final exam, very, very important for the next courses that you're going to take. In particular, if you're going to take 240, you're going to talk about this again a lot for several months. So please, as usual, review the slides, copy paste the source code, run the programs, see what happened, play with them. Do not be afraid to create the errors and fix the errors. See what is happening. Be sure that you understand this. If you have any question, please send us an email. Good? So see you tomorrow. Thank you, guys.